Hello, everyone. We'll be presenting today our progress on our project, BOLD, which is the Bayesian Online Lie Detector. It is myself, Abdullah Hassan, and Farid Khan who are going to be working on this project. So what we'll be going over today is just an introduction of the topic, our proposed solution, which will include the Bayesian deep learning aspect that we'll be working on implementing, and the results that we are getting and hope to get from that, as well as where we hope this will go in the future. So our project is based on the identification of fake news. Fake news is basically any sort of content or misinformation designed to manipulate people, spread propaganda, support the claims of a certain group. And we see that in a very modern context politically, but it can also have an effect with parody articles from institutions like The Onion, who solely exist to create such headlines. And so the New York Times defines fake news specifically as a made-up story with the intention to deceive, and often with monetary gain as a motive. So here are some examples of fake news headlines that have been picked up, such as an FBI agent suspected in Hillary email leaks found dead in an apparent murder-suicide. And then we see examples, a Twitter example. This is a little bit older, where 2 explosions in the White House with Barack Obama injured, but we also see a lot of this more frequently now, and how social media is trying to tackle this problem. So the characteristics of fake news are the words and languages arranged specifically to manipulate human psychology. It's more likely to be spread by humans and robots. Often the titles have a lot of shock value, and they're something people will very easily pin onto, and so they create a desire to share this sort of big information, and so it'll often create fear, disgust, angst, surprise, really strong emotions that would prompt someone to share it. And so our proposed solution, as before, is BOLD, which is Bayesian Inference Online Lie Detector. And so Farid will explain the particular details of this.
Yes, hello. As the name proposes, it's called BOLD, Bayesian Inference Online Lie Detector, which basically has a property that we're using Bayesian as a classifier. Online is going to be because it's going to have a web interface, so it will provide you the answers real time, and it's to detect lies or fake news. So the basic premise that we use is fundamentally the Bayes theorem, which we also discussed in the previous slides. So it's a technique in which prior experience is used as is updated as more data is available. And as is shown is in the next slide. So what we see here is on the left side, we have the posterior probability, which is the posterior probability, which is that when a given evidence, how does the hypothesis probability is affected? Then we have the prior probability, which is the PC, which is simply whatever the hypothesis occurs with respect to the probability. And then you have the likelihood, which simply shows that the given hypothesis, what is the probability that the evidence or the cause will occur. And then you have the conditional, which is whether the evidence is true. And this is fundamentally is used in order to update as more data is available regarding any certain topic. So, for example, another case would be that given a case that a political event took place, what is the hypothesis that it will carry around it? So one of the properties that we have seen and has to be applied is that Bayesian inference and parametric models are to be used for multi-neural network. This is still a very open and advanced research topic. There is not only need of algorithms, but new approaches are to be needed in order to handle sophisticated um, or more situations which might be unpredictable in terms of even fake news usage. So so here, this is also one of the reference material that we're trying to use. So it shows in terms of as for the graph model and in terms of like a TensorFlow system. So we can see as each vertex or each node represents certain prior probability that it carries or certain information that it stores, and there's a mechanism that is to be used how it's going to be updated. The DAG structure is basically known as directed acyclic graphs, which is simply that graphs which do not have loops or cycles in it. And so this is very similar to the way that non-RNN models work because they do not have loops in them. So it's very similar to a feed-forward network. And so as more information is available, the nodes either you can call it as the loss functions, or the probability that it tends to be carried is how it's going to be updated with respect to whatever loss function that you're trying to use for it. So this is a similar kind of model that was used, but it's not used for fake news detection. This is particularly used for something as reply aided detection. So we are trying to model and program something very similar to this. So what it does is, as we see on the first part where it says claim encoder. So encoder is simply a way that you wrap up the information so that the main intent or the most important part of that data is not lost, but it still can be used in a multidimensional way. So if you're using a tensor, it's a very good way to use it. So then all those words will be fed into a word embedding process. So each word will carry its own certain probability that will be fed into the word embedder, and it gets a certain number, and that will then go through the LSTM. In our case, it would be just a Bayesian neural net, multi-class neural net, and after that, it processes the information to give you result whether it's going to be fake or true value. And it also does use Bayes normalization and loss function to be applied accordingly to get better results. So the data set that we are trying to use for now is called the LIAR data set, which is mostly got from political fact journalists. It has about 12,000 different statements, and the kind of labels that I tend to use are 6, depending all the way from 100% true to false, half true, and then total lies. There are very similar other models that can also be used for the data set, which are kind of like Fever, BuzzFeed, which are used for Facebook data, fake news data set. And there's FEMI, which is used for Twitter's. We are still under the process of implementing our model. And one of the problems that we tend to face is the kind of libraries that I'm trying to use for it. So that's one thing, and the second thing is just working with TensorFlow implementation aspect, which is itself is kind of learning curve, but we expect to get better results with due time. And also there's this package that we're trying to use is called ZooSwan. I don't know if I'm saying it properly, but it's a very powerful Bayesian probabilistic deep learning framework, which was proposed in recently, which can be applied for our model. And I think that if it's properly implemented, we can have very good results with neural net based on Bayesian model. And I think Abdullah would like to speak about our further development.
Thank you. Yeah, so as Farid mentioned, there is a learning curve to TensorFlow, and of course some of the other software libraries that we'll explore for this project. Once we have that working, we hope to make this this research accessible and available through a web interface, with which we have a very simple example here, but in theory where a user could just input a link to an article or a tweet perhaps, and we could give them a relative probability based on the model of how likely it is to be factual or fake news. So for our future work, we aim to fix any library issues and improve our code implementation and achieve a benchmark performance as a benchmark performance result for the LIA dataset, and then write an IEEE standard paper and reformulate the Bayesian deep learning algorithm with symbolic regression logic and the Markov chain model. And then in our final presentation, we hope to demonstrate the results that we've gained and the graph plots. Thank you for listening.